All right, on to Chapter 7, where we start with the text mining, text analytics, and sentiment analysis. So in this chapter, we're going to go through text mining, understand why it's still needed, and what the difference between text mining and web mining and data mining is, and different application areas we might go through to do this. Some different methods to introduce structure to text-based data. So it's all about the text in this chapter. Talk about sentiment analysis, some popular applications, and just kind of look at speech analytics and kind of walk through some of those constructs. So in this day and age, 85 to 90% is some kind of unstructured form. In other words, it's text in just random places. Unstructured corporate data is doubling in size every 18 months, and I'm not thinking that's going to slow down anytime soon. We keep generating more and more documents and emails and all kinds of information that's out there. It's going to keep doubling, so that's going to be a considerable amount of data to work through in the coming years. Obviously, it's not just an option to use these data sources, but we have to keep competitive in our business climate. So our answer is a text mine. And really the definitions we're going to go through is a semi-automated process to extract knowledge. Remember, we have data, information, and knowledge. We have knowledge from unstructured data sources. So previously, pretty much unusable, just plain old raw data can now be put into information and then knowledge into really useful types of systems, and then also put into textual databases. We can actually learn, put it in knowledge bases and such. So this is kind of another little map of how text mining can kind of come about, similar to how we looked at data mining a couple of decks ago. We have all these different things across the bottom of how this comes together. Still plenty of computational and statistical and management kind of stuff going in, some AI down there, some machine learning, so that's kind of repetitive as we were before. Now we're looking for the text analytics. We have web mining, data mining, doing some extraction, some retrieval, and all these things kind of come together to do text analytics. So we want to talk about data mining versus text mining next. Both are seeking novel and useful patterns. Semi-automated, doesn't take a ton of training to go through this, but the real difference is in the data. So structured versus unstructured. Structured data is already put into databases. The data type is there. The fields are validated. Hopefully, it's put into a nice format that we can actually use. Unstructured is what you're used to. At least on my computer, it is. We have Word documents, PDFs. We have all kinds of stuff, including emails that are out there, and they're just not in a real order or format. And so text mining goes about that unstructured data to impose structure on it and then mine that structured data. That's really the big difference. So some concepts we have to work through are where the benefits come in. So you can imagine anybody that's got a lot of this information. So the first one would be anytime you work through the court system, you can imagine the tons and tons of documents they've got, from cases to the minutes from the courtroom to all the pleas and all that kind of stuff that's out there. It's just tons and tons of stuff. And obviously you want that to be searchable so you can look for precedent from the past. Certainly research for people getting their degrees, whether it's just basic papers, whether it's a master's thesis or a PhD. You really want to have your ability to search and research this stuff that's already out there and not try and reinvent the wheel. And then some of these we've also seen before, whether it be finance, medicine, biology, technology, etc. Just kind of get things done in the most efficient way possible where we can text mine. And then likewise, we can also use this to our advantage for searching for spam and for categorizing email and for coming up with automatic responses. There's a number of chat systems now where a live operator doesn't necessarily get involved until the question is so complex, doesn't have an answer for you. They can text mine previous answers and previous knowledge bases to give answers even via chat. So it looks like a person's there, but the person's not actually on the other end until it gets to a certain point. So some of the information where we see applications for this, extracting, working through topics, summarizing data, categorizing data, clustering data, linking concepts together, and answering questions. So anytime we have a use for these types of activities, text mining could be the answer. Obviously, we need a good sample base to work from to get to this point. But again, if information is doubling every 18 months, it's not hard to come up with data. But once you got a nice sample set, you can pretty easily do this. So some of the terminology we use are let's see, unstructured or semi-structured data. We have to have that, obviously. The corpus, which means body in like Latin, I believe. terms, concepts, stemming, stop words, synonyms, tokenizing. So these are all kinds of terminology that we're going to use when we work through the basic text mining processes. So we need to understand kind of what we're trying to accomplish, and we can put these words to use for us. And next we have a dictionary. We have a kind of a frequency. We have some decomposition going on. So again, more terminology, what we're trying to accomplish here. Again, the book's going to spell this out more clearly by definition for us. Something that's relatively, well, it's newish anyway, is natural language processing. And what we want to do is working through a collection of text where we have natural language instead of trying to program it. So the old approach would be we had just a bunch of words and trying to make sense of that, but now we try to understand how language is spoken, how sentences are formed. It's important in text mining. Really, it's almost a subfield, and I look at this coming at from a programming perspective, from software development, where it is natural language programming, where you write applications in a language much like English. You use verbs and nouns and things like that, and it's not quite so cryptic as it would be, with the older style languages. And this is very similar to that. We're trying to do processing and go through data text mining with using natural language instead of the more complex language. So understanding, obviously humans can understand, but what about computers? Certainly natural language is not really always clear, even when we're speaking to each other and we're trying to understand. A lot of it is context driven. So what's the surroundings, kind of what was the last thing you said, what's the next thing you said, how does this fit in the middle of that? And to have true understanding, via human or a computer, it does require extensive knowledge of a topic to really get to where the understanding happens. So part of the challenges are we've got this part of speech tagging. So if you can just think back when we were learning parts of speech, which are nouns and verbs and pronouns and adjectives and adverbs, etc. But just think of homonyms, how much trouble they can be. You can have word sense. So sense like 50 cents, sense like my 5 senses, and then or that makes sense. So there's different ways of spelling, different ways of pronouncing, the same words, and just how do you teach a computer that? Because it's all context driven. When I'm talking about 50 cents, I probably don't mean, my hearing or my sense of touch. I probably mean, the dollar value of cents. I also, sense could be SCENTS, meaning like a rose has a scent, the scents of the roses. So there's, again, another homonym for that. You have to look at the context around how that word is used, understand which of those it could be. So just a quick example of how parts of speech, it can be difficult. Word sense disambiguation probably fit there as well. So how do you pick apart a word that maybe not make sense? How do you make sense of it? Also ambiguity, and I guess we're saying kind of the same type of things over and over again here. So ideally, in the AI community, the dream is to have algorithms that are capable of automatically reading and obtaining knowledge from text. That would be great. So in other words, could you give a manual to a computer to scan in and to read, quote unquote, and to understand, quote unquote, and have it get enough context, enough understanding to actually have knowledge from that? That's the dream. I think we're certainly getting close to that, but it's still a ways away because there's so much, there's so much context for that. It's really hard to put it all together and have all the bits and pieces to make it make sense. So here's a couple of examples of more NLP. So Wordnet was put together. It's a resource for NLP where we have a very laboriously hand-coded database, synonyms, all those other kind of things put together. And basically this is a tool you can bolt onto your NLP. And then there's sentiment analysis where you can have favorable, unfavorable opinions detected when you're talking about specific things. So you can imagine if someone's done a product review on Amazon, they probably do sentiment analysis. Are they happy? Is 1 star actually right? Or do they actually mean to click 5 stars? And is that worded right? How does that mean? So some basic tasks that can be handled inside of NLPs. You retrieve and extract. You try to answer questions. Do some summarization, maybe some translation if necessary. What does that actually mean? What does the subtext actually mean? Do some speech recognition. Do some proofing. So you may do some, or maybe not all of it, but you may do most of these categories during an NLP type of process. So here's the applications for this, for text mining. Better CRM capabilities in marketing. You can do some security applications where you're looking for almost behavioral type of things before you can gain interest in something, almost like almost like a token for one of your multi-factor authentications. You can look for, here they're talking literature-based gene identification. Well, that would be, I think, a stretch, but I guess it must be true. Academic applications where you look for a variety of media types and put in an analysis to that. So the next slide here, we have a graph looking for, so we're doing some biological gene and protein kind of understanding, identification. You've got all this information broken down into words and letters and numbers to try to identify, trying to draw some kind of correlation or some commonality between them. So, yeah, go team. That's good. Next is a context diagram. I'm trying to understand how this stuff fits together, what relates to what else. So, again, trying to understand, try to teach a computer to understand or to learn and gain knowledge from a variety of text sources. So in this slide, we've got the basic, a couple of steps here, 3 steps. Establish the corpus, but again, that's establish the body of knowledge, basically. Then you want to do a term documents matrix to understand how that fits, and then you extract knowledge out of that. So it's basically an iterative learning process. This is how we teach a computer how to read, understand, gain knowledge from a text. I'm just going to walk through this step by step here. Step 1, step 2, step 3. So first we have to establish the body, digitize, put it in a common place. So this is kind of bringing in, whether it's log files, web pages, text documents, whatever it is, bring it all in and put it into a standardized form. And term by document matrix, make sure the right types of words are used in a certain type of documents. You're kind of doing some categorization here. You kind of figure out which words belong in there, which words are stop words, where the words stem from, what's the root of each of those words if you don't understand the word, how frequently they happen, kind of going through all of this. So again, there's some real science behind this. This is certainly not something that's elementary at all. There's really a lot of work goes into this to make text mining valuable. And again, the good news for us is we're going to take advantage of the tools already built. We don't have to go and design this from scratch. There's already a system in place for us to take advantage of. I just want to kind of show you that background. This is what somebody really had to think through. And again, these were developed by PhDs, people that sit in a lab all day and do this kind of stuff. And it's just interesting to see how their process turned out. It's kind of much like you teach a child to learn, to read, and to understand words. You start with the small words, get bigger, get in context, how to pronounce words, what other words are like it, etc., etc. And then we're kind of still in step 2, working through that matrix, including getting more expertise that goes through it. And then the last one is extracting the patterns and the knowledge out of it. So kind of once we gained all that previous step 1 and 2 data, then we can work through step 3 here, which is getting better at classifying, clustering, and doing some analysis on it. So next, I want to go through some tools. So IBM has a modeling tool. It's a text miner. SAS has a tool that's a data miner for text. There's other commercial tools available. And then on the free side, the open source type of tools, there's RabbitMiner, Gate, and SpyM. And so just going to point out some options out there. Again, if you were going to use the commercial tools, they would usually come with a whole, usually training and a whole bunch of that kind of stuff. The free tools, you have to kind of dig and find out what kind of documentation is out there and go about it on your own. So when doing a sentiment analysis, again, this is where you find out if it was positive or negative on something specific. You have to work through beliefs, views, opinion, convictions, and understand, are we doing, is it favorable or not? And the question is to answer, is somebody favorable about a certain topic? Positive or negative versus neutral. So here is a tool. Looks like we're using Attensity, trying to do some analysis on a brand. We're looking at social media posts, understand if it's favorable or not. So this is kind of stuff that's going on right now. People that have Facebook business pages can look at this and run a tool like this and find out, how much is being said, how much is favorable versus not, where are they coming from, all this kind of stuff about it, and just watch for trends. I think that's kind of interesting. So I think this right here is fascinating to find out what you actually use this for. You get the voice of the customer. I think we talked about this in a previous class. If you go to the Best Buy Facebook page, there's not very many happy customers on there, so I'd be interested to see what their analysis looks like on their Facebook page, because there's so many people ranting and just negative and upset about everything, and everybody's just not good to them at the store. So it's interesting to see the people that claim they're customers anyway, so whatever that means, but it's interesting to see that perspective. Then there's the voice of the market. So you could probably pull data from a variety of sources to find out what the general tone of the market is. So if I was selling on Amazon, I might want to look at reviews from other competing products or from other related kinds of items to find out what the voice of the market is. Voice of the employee, again, wouldn't be very hard to relate that together. Going through the other brand and financial, political, etc. Types of ways to use this. So again, you can find out is our candidate for election going well or not. We can look at a whole bunch of comments and feedback or emails or whatever and determine the sentiment. Is it positive, negative, neutral, kind of where does it stand? And that's how they get some of those polls that are done like that, even though it's not a direct interview kind of a poll. So this kind of walks through a sentiment analysis process. And so we start at the top, kind of get the polarity. Again, is it favorable? Otherwise, the lexicon is kind of that word dictionary that you can use. Is there a sentiment to it? Kind of what is it? Again, favorable, otherwise, positive, negative, etc. And it just kind of goes through, and you just look at that graph or whatever. The last step is kind of tabulating the results, if it's favorable or not, or what percentage is what. And then this is the walkthrough of that, and there is not, no, there's not any math in this, I guess, but just kind of walks the text through what the steps are. You're going to detect the sentiment. Is it positive, neutral, etc. for polarity? Do some identification. Is it expressed correctly or not? Is it correct? Do some validation, and then collect and aggregate the end data. So the polarity, positive or negative, can be made at the level of the word, and there's a couple of methods. One's using lexicon, and Wordnet is that one that was out there, and Cento Wordnet is the other one that's out there. Otherwise, you can use pre-classified training documents. So again, training is when you have a system that you're training to learn that these words are considered positive, these words are considered negative. So you can use a pre-built one, or you can use a already classified document to learn from. That helps identify the polarity. This is a little chart that shows once we run it through a positive, negative versus subjective or objective polarity, you kind of find out where on the chart it's going to end up. So subjective versus objective, are they an actual voter, or are they just speaking on a turn, versus is it favorable versus not favorable, so you kind of get a judge of where things are, figure out where those clusters are of data going all the way through the sentiment analysis. So there's also a speech analysis, which is related to that because it uses an input from a microphone or from a phone or from a whatever to get the words, but also other voice features, which has takes more of an acoustic approach where you take intensity, pitch, jitter, shimmer in someone's voice as well as the words. So you can use either one of those types of approaches. So the linguistic approach is how many different words of different parts of speech. They show the taxonomy of speech, figure out how complex of words, how many industry-specific words. So different kind of ways to use speech analytics to go through this. This is relatively new for a research point of view, but I suspect we'll see more of this. Just think of this: you could use this on a presidential debate. You could use this during a job interview. You could use this during all kinds of different approaches where you've got the ability to have the human voice understand this. You can use it in a call center. Anytime you get a voice or a telephone or a microphone, you can take advantage of this type of analysis. So, and that is sentiment analysis. There we go, and that's it. All right, and here we go with Chapter 8, the last chapter this week on web analytics and mining and social analytics. So in this chapter, we're going to go through defining web mining and go through all its taxonomy and other application areas. We're going to look at between web content mining and web structure mining, and look at the difference in text mining in this as well. Look at some of the internals of web search engines, some more details about search engines, and go through some web usage mining and its business application. And further, go through some analytics maturity model, go through social networks and social analytics, and go through some of that as well. So first of all, go through a web mining overview here. Obviously, the World Wide Web, the internet, is a huge repository of data. It's difficult, if not impossible, to quantify in someone's mind how big, how much, there's so much that's out there in all kinds of formats. In HTML, obviously the hypertext markup language, XML, text. Certainly there's PDFs, there's pictures, there's videos, there's all kinds of stuff that's out there, including PowerPoints like this one. So certainly some of the challenges are there's just too much, too big to do any really effective data mining, or so we think. It's complex, it's dynamic, meaning it changes all the time. It's not specific to any domain. It's not just financial, it's not just medical, it's not just technology, it's all over the place. And there's literally everything. So it's really, really hard to do. So both opportunities and challenges there, and well, apparently they're really great. So web mining is a process of discovering relationships between web data, whether it's textual, whether it's links, just how the web is used. It's not quite the same as data mining. It's not just text mining. There's a lot of different stuff going on, including the content. In other words, including the pictures, the movies, the PowerPoints, the Word docs. All that stuff is there. How do you relate it all together? Then there's mining versus analytics. And we'll go to the next slide and take a look at how this fits together. So there's web content mining. So it's unstructured text data of web pages. There's web structure mining, which is looking at the URLs, in other words, the web links, the full URL and path name behind it, and then web usage, which tracks user activity. So I've spent a good part of my life working through the design, the hosting, the promotion, the marketing aspects of web design and hosting. So I'm certainly very interested in this because I've done this for a long time, and it is, although it looks simple, there's a lot going on here. So the green bubbles below kind of show some of what we use as tools and kind of what we can see from an analytics perspective. It's kind of interesting. So obviously we can pretty easily mine the text content. So if a website has just regular HTML text, we can pretty easily put that together, keywords and stop words, and kind of get the context around that. That's done via web crawlers or spiders. Almost all of this is automated now. Way back in the day, you had to go and tell Alta Vista, if I can use myself to date this, oh goodness, you had to go tell Alta Vista, you had to go tell Yahoo to go and index your page and go and dig through them. But now, as long as you're found somewhere, you'll probably be indexed within a few days of each other. And then because each page is linked to something else, and you want to have pages that are higher on the chain and lower on the page, lower on the chain. So you have those authoritative pages at the top of the tree. You have those lower pages that are kind of linked to all of that. And so you can go through and again get a pretty good index of what's happening based on going with a crawler. So modern search engines, there's really a couple of key players, and the rest just kind of follow way behind. Certainly Google's probably certainly my favorite, if not yours as well. Bing is an okay player, and Yahoo is just kind of fumbling along, I think, more than anything else. And so a search engine, just from a definition perspective, is a software product that goes and looks for words, for terms, sentences that have something to do with a topic or a subject. And they really do the majority of the work on the internet for people to find what they're looking for. I certainly wouldn't know which manufacturer to search for a certain product I'm looking for. For example, I'm looking for a VMware backup that does not use vCenter. So it's basically an ESX-based backup. I can't take advantage of the vCenter automation and hooks, so I have to use something that's pretty automated. Basically, it's going to be a shell script, but I know someone's developed those. So how do you word that? I don't know which website to go to. I mean, who makes that? So I have context on what I want, but I don't know who or what the product name is or anything else. I have to search for it based on context, and that's where search engines can really help me. To their credit, I've certainly found a variety of choices. They're priced good. They're certainly either low cost or free, but it's easy to find what I'm looking for based on the right keywords I'm putting in. I'm sure you've witnessed the same. Here's a little bit of a diagram of showing what's really happening here. So on the left side is kind of the consumer view. It's really the user and the big database of all the stuff that's out there, and they spelled cache wrong, which is funny. And then on the right-hand side is how it's gathered. They send basically a spider to go out and or a web crawler to go out and just go link to page to link to page to link to page, and go through and scan all that text and all that content and all those links in, and then put them in indexed form back in the database. Then the user can obviously go through and do queries and make sure do an analysis on the query, make sure it's right, and then obviously return the results. Now just think of all the data that Google has. Think of all of the data all of them have, really, but Google is obviously the biggest player. Think of the data they've got. They know that in a certain area, a certain state, a certain zip code, searches that are going on right now. So they know what news is long before it's ever reported. So the newspaper probably can use Google as a tool just to find out what's happening, what's hot, what's hopping in an area just by watching what current searches are going on. And certainly Facebook has the same thing, because you can see the news kind of feed in your right-hand side of Facebook where they show kind of what's trending. Well, they know. People are talking about it. People are writing about it. Same kind of thing happens. They analyze all that. All right, so next here, they just kind of go through the diagram we just went through. We go through the development cycle, goes out and crawls. That's that right-hand side, the development cycle. So they go through and index, pre-process the documents, parse the documents for what's relevant, and getting that context there, getting that term by document matrix set up, figure out how frequently things happen, the words that are in there, and then likewise the response cycle is that left-hand side. So we come back up here. The left-hand side is the response cycle. It's the end user kind of interacting with it, doing queries, and then getting the response back. So how does Google do it? Well, there's a lot of science behind it. Really, they have some pretty good training videos on how Google actually works, with nothing proprietary being shown, but it gives you an idea anyway. Googlebot is their web spider that goes out and indexes, goes out and follows the links. Indexer goes and does the processing and understands what each of the context of the pages is and that the links are. Then the query processor on the left-hand side, which would, again, look at my input to the search engine as an end user and make sure it's correct. It's just amazing what you can type into Google. I mean, I still find top hidden Google features. I still find new ones of those I've never seen before. Like, I didn't even know you could do that. You can do a currency conversion right in a search. It doesn't even go out and do a search because you don't need to. It just figures it out for you. The query analyzer does that for you. I'm doing a Bitcoin to USD conversion, pulls it right up. And if I've got 0.003 Bitcoin, how many US dollars is that? I have to go out and find a website that has the current value of Bitcoin. Google calculates that for me. The query processor does that, does the analytics for me. It's pretty nice. So PageRank is really Google's secret sauce when it comes to making them different. They've got a way of ranking what it believes as a relevant results to your query as an end user. And so this algorithm is constantly being tweaked, and it's something they're very well known for. And so it came about as a project when they were at Stanford University in the 90s. And again, they call it secret sauce here because that's really what it is. Now they show some math here. Certainly we don't care about this math from a class perspective, but it's interesting to see. I'm positive this is not how it is today, because again, they keep tweaking this and updating this, and we'll find out why in just a couple of pages. So one of the ways to get better results in a search engine, so to get ranked top, or close to the front of the search anyway, is to do optimization, where you put your strategic words and phrases and links and all these things that can have a weight and to get closer to what your clients or what your constituents are searching for. And so it really helps to understand what that third bullet there, based on knowing how search engine works. So Google has a certain way, their PageRank algorithm, how it works with content and keywords and links and such. And Bing is similar but slightly different, and Yahoo is again similar but slightly different again. Knowing how they work is going to certainly be to your advantage. This is kind of a ranking, and this is from 2013, so it's pretty old data now. And I mean, just the monster lead that Google has. I don't know if the gap is quite that wide anymore. Microsoft has stuck a ton of money and marketing in Bing, and the rest of them can pretty much fall off very quickly. I'm sure that's still true, but I'd be curious as it would be today. Google, Bing, and Yahoo are still the major players. What is the spread between the three of them now? And I bet you that's 98% of the market between those three, and the rest are just fighting over the crumbs, really. So if some of them aren't around anymore. So there's a couple of methods. I would only endorse the white hat SEO, because black hat SEO really just gets people in trouble. Google especially has gotten really smart about people spamming web pages just to get better ranking, and so I really would not recommend that at all. But there's plenty of people still trying this, and they're successful for a while till Google rewrites the algorithm and kicks them out. But the white hat SEO is really just using common sense and good design and not playing games with the system. And it's really designed to have content, again, for users, not just search engines. So it makes a good experience for both, for the search engine and for the end user. But you really want to have quality product, and that takes time. And of course, anybody that doesn't want to do that is going to cut corners and try to use the black hat techniques. So another technique from our web tools here is analytics. And this is really interesting for me because this can come from a variety of places, and I want to know how effective my web page, my website is. I can look at server logs if I want to. I can look at how the usage is. I can look at metadata. I can look at all types of different analytics tools that are developed for looking at website usage. So Google Analytics fits here, and so that's a third-party tool where Google analyzes the time spent on each page and kind of what the user does in each page. And there's plenty of server-based, log-based tools that can do the same type of thing. It can really tell you the effectiveness of your site based on how the pages are used. What links do users click on the most? What page you get clicked on the least? What information is actually used by the end user? Here's some applications for it. Lets you set up some cross-marketing strategies. Figure out if a promotional campaign is working or not. A classic example of that is you can have some pages that are not linked to the external site. So, for example, we could have msbcollege.edu/billboard, and there's a page inside of there that's not linked anywhere else inside the site. But we can see how many people land on the /billboard little microsite, and then go inside the site and then go to the rest of the site that is linked from there. We can figure out, did that campaign do any good? We put that /billboard on a billboard and then see how many people drive by and actually click the link and do the thing. It's kind of interesting to see that. Now, this kind of marketing's been around for a while, but it's just interesting to see how you can take this forward to websites and then you actually make changes to it almost in real time if you need to. So, because these kind of sites can be set up fairly quickly, and then really take advantage of the technology. So here we're kind of going through a little bit of information where we have some clickstream analysis going on where, again, we have the information in front of us. We can decide, well, okay, here's the website that they go to. Here's where the page that they click on. We can look at that and find out, well, what's most effective, what type of users click here, what type of lifetime, what's the length of the stay on the website, and then what do we do with that data? Do we make the site more engaging? Do we update it? Do we add more pictures? Do we add more links, incoming or outgoing? There's all kinds of different actions you can take on that. Another analytics metrics, you can use it to improve site usability. So on some sites we designed, we found out that some pages were never even being clicked on. In other words, it was just too hard to get there, or it was buried somewhere in the site and they were never going there. So we wanted to make it easier to get to those pages if they had relevant information on them. Want to have better ROI on our documents. Want to be able to emphasize some information on the website. We can certainly do that with some of this information. Improve usability. Again, this is some other categories here. Where do the sources of traffic come from? Are they all domestic? Are they from Minnesota? Are they all foreign? Where do they come from? What time of day? What do the visitors look like? Are they from a city, or where are they? What's their profile look like? So the conversion statistics are really interesting, I think. This is usually when you get into a shopping cart, or it could be just even filling out a form for more information. How many people go into the website but never click the contact page? How many people go into the website and buy something? How many people go to the website, put something in their cart, but don't check out? So that kind of conversion of going from one part of the website to another page, that conversion can really be all the difference between making money and losing your tail on it. So this kind of puts some comparison side by side between usability and traffic sources. Also just came right out of the book. And likewise, we've got profiles, some information about that, as well as the conversion statistics. Really helps understand how the site's being used. This is an Google Analytics web page. Yeah, if you wanted to buy some marketing from Google, or if you just wanted to analyze your page for free using their analytics tool, this will tell you at least that this is just one very, very small piece of what you can see. So if you've got a conversion ratio plugged in, you get some revenue out of it, how many visits. Bouncing means you hop in and you get right back out of the site. How many average time you're spending on the site. So all of this is going on most modern websites. I don't know if you've ever seen this before, knew this before, but this is exactly how the websites I worked through, we analyzed all of this right to death, just to understand how customers are using their websites. Very, very handy. And this tool is free if you use Google Analytics. So there's more to it if you want to buy ads, but this tool comes for free to Google Analyze your site. So it's very interesting. It tells you your web browser, tells you if you have any, what percentage of users. Kind of breaks it down really nice. Like, I feel sorry for those IE users. Frankly, I do. So this will help you gauge. These analytics will help you gauge the maturity of your website. If we're doing things in a optimized business model kind of a fashion, There's some models we go through just starting out with analytics. First, you're just doing reporting, doing some spreadsheets and spreadmart kind of data information. Then you go data warehouse, then you go into BI services. Now with other business analytics maturity model, you get from descriptive, just kind of telling the story, kind of predicting, and then prescribing what you should do before it even needs to be done. So kind of you can see the more infantile to the more mature in both of those regards. When we do the web analytics maturity model, you have these 6 different kind of spokes of the wheel. You kind of see where where a company is. Okay, so from a tools perspective, which of these is your company do? You can say, okay, well, there you are. From a management perspective, which of these things do your company do? From an objective perspective, just going to go around and figure out what your shape looks like from a maturity model, and find out where there's work to be done. It's very, very, very hard to be 5s on all of these, but I mean, you want to be as pushed out as you can, being the most mature that you can. And it takes time, takes resources, takes money. It's hard to do, but to stay competitive, you want to be as pushed out as far as you can, because that's the most mature. So lots and lots of tools exist for web analytics. I've used handfuls of them. For sure, AW Stats is a pretty basic one. It's also free. I've used Google Web Analytics a bunch of times. It's also free. It works very, very well. These are AW Stats is a log-based tool. I think you can have a hosted-based tool now too, but this basically looks at your web server logs. Google Analytics is a hosted tool. It basically puts some JavaScript code on your page. And the rest of these, I'm sure, follow one of those categories as well. Helps design pretty graphs to understand what your site looks like. So this just kind of gives a 2-dimensional graph of how the tools can help with optimization. And here is some more information about if you've got your interaction on the web, here's your ability to do analytics on that, and then what do you do about it. So we understand a holistic view of the customer, what's going on with the industry, what's going on with my customer service, what's going on with my customers, bounce rate, etc. I can use all of that to my advantage using these tools. So this is a customer strategy framework from Intensity. It looks like this is from the same company we saw in the last deck. Lets you really take a 360-degree view from all the different things your customers can communicate with you on, whether it's a survey or an email or a chat, otherwise external sources. Analyze that, put it in relationships and find out, with your other systems and take action on it. And hopefully this helps turn around upset customers, help you emphasize on happy customers. You really take advantage of the data that's there. And there's a lot now to take advantage of, obviously. So then we're also going to do social analytics on social network analysis. So you can imagine with all of the rise of between LinkedIn and Twitter and Facebook and all those different social networks, there's a lot of analytics that can be done. You can look at social psychology, some sociology, certainly some stats and other graph theory to see how things are fitting together here. Social networks are really kind of a strange thing to see because they you kind of write your own statistics as you participate yourself. And the customers just kind of self-organize. The groups become self-emergent, and they certainly are complex. There's a variety of types of social networks. So I mentioned, the common, Facebook, Twitter, LinkedIn, all that kind of stuff. But there's also other types as well. Community networks. There can be criminal networks, underground type of things. Innovation networks that are kind of private. All kinds of ways to look at this data. So some ways to kind of slice and dice the data. You can see how like or how similar something is, how complex it is, how the market is segmented, how much together or apart, how much cohesion it has, how the distribution looks across a plot of data. It's really interesting to see how this can really tie together or be disparate, and even at the same time. It allows you to see how technologies relate between people. What things they have in common that are certainly not obvious. This is like data mining, only taken to social media. You can imagine it gets pretty crazy pretty quick. And again, there's a variety of forms on here. They even mentioned podcasts and wikis as well. So pretty interesting, I think. Here's some of those categories of social media. So Wikipedia, I know I use that quite frequently. It's usually a fairly decent third-party tool. It's not the only source I will cite for a project, but it's a good way to start anyway. Oftentimes Wikipedia, for me, I look at the links for the notations at the bottom. Like, where do they get that data from? I can go and look at the actual research itself. Of course, they get YouTube, Twitter, Facebook, some gaming sites, and then other specific social worlds. I think my daughter plays The Sims on here, and that's in here as well. So social media is different than traditional industrial media such as newspaper, television, and film, just because it's much more portable. The quality is going to be very different. The reach of it's going to be different at different costs, as different. All these things kind of play into that. So the usual media was pretty much one way. You just think back in the 80s and 90s when you watch TV, the only way that the company knew about it is if they sent out a poll, the Nielsen ratings. Where now, every time someone watches a Netflix, they stream Friends on Netflix or whatever, they know. So they know how many people are watching it. They know what zip code you're in. They know how much you pay for it. I mean, all the stuff is there, whether you like it or not. So industrial media is taking advantage of that as well. And even the traditional newspapers are all allowing Facebook comments or other third-party plugins to comment on there. So it's more of an interactive, quote-unquote, experience. Because the traditional paper newspaper is dead and gone long, long ago, obviously. So there's very few being printed. But the online newspapers are trying to make up some of that by keeping it sticky. They can get the interaction where you can comment on the news, where you can interact with the news. You can add your opinion if you'd like. So here's the various engagement levels of social media. People that don't use it at all on the lower side on the left, all the way up to the creators of content on the right. And there's all those in the middle. So it's interesting to see where you fit. I'm probably more of a... I'm probably right in the middle. It depends on what it is, a collector or a joiner. That's probably where I am. I don't do a bunch of creation. I guess these videos I'm doing for class are slightly on the creating side, but really I don't usually do it that often, just because that's not who I am, I guess. I don't really want to, but whatever. So. All right, so some of the analytics, you can imagine it'll be very similar to how we talked about in earlier web analytics. You can really see the sentiment analysis. You can get all kinds of insights and hopefully take actions on things more quickly than waiting for a report to come at the end of the month. So HBR's Harvard Business Review is a very well-known analysis tool. They do a lot of research over there. And they just did an article back in 2010. So this is really data and information. 75% didn't know where the customers were talking about them. I'm positive that's different now. And the low number of 7% able to integrate social media into marketing, that had better be completely flipped around, where it's 93% are now, and maybe 25% don't know. I mean, that should be completely flipped, 6 years later. Even with my little consulting company, I'm doing a good chunk of this. Facebook provides us with my business page. You can really see a lot of data, male, female, zip code, all the stuff that I want to see about people that like my business page. It's so easy, it's not even funny. Without even trying, it's that easy. So. Likewise, measuring impact, we can do an analysis on descriptive things, kind of finding out just basic counts and statistics, and then we can try to do prescriptive things or predictive things as well by looking at what the interaction is and what the outcome should be. So here's some best practices. I think you can just read through this. It's pretty straightforward. I think nothing real surprising there. There's also a variety of tools on this page. Again, if you're going into that as a job, you might want to just consider some of these as tools. Salesforce Cloud really drives a lot of other applications. So you may have heard of Salesforce as a tool, and you can use it for a lot of things. A lot of companies pile their tooling on top of Salesforce because it's got a good framework underneath it. So I've seen ticket sales done through Salesforce. I've seen certainly the sales process done through Salesforce. Just depends how you skin it and kind of what other things plug into it. So it's kind of interesting. This shows Sprout Social as a social media analytics tool. Just kind of gives you a screenshot of what you might see. This looks kind of similar to how Facebook, if you looked at just Facebook, would show that. Looks like Sprout allows you to kind of combine things together with Facebook, Twitter, etc. How your social analytics just looks in general. So it's an overview, kind of a dashboard. And that is the end of this chapter.